Hi everyone, I'm Till. I'm a co-founder of Restate, and today I want to tell you a little bit about durable execution with Restate, which I believe is one of the simplest way to build workflows as code. And I hope at the end of the talk you see it a bit more like me. So let's get started. To begin with, let's assume we have the following task, which is implementing like a food order processing function that consists of the following steps. First thing this function should do, it should process the payment. This is integrating with an external payment provider like Stripe, for example. Second thing would be waiting until the food order should be prepared, because the food order could be placed for the future, right? Next thing would be we need to inform the restaurant that the food should be prepared, and once the restaurant tells us back that the food is ready for pickup, we should tell our delivery driver to pick it up and bring it to our customer. That's the task or the function we are supposed to implement. Now my question would be, how hard would it be to make this reliable, so that also in the presence of all kinds of faults that can happen, we won't charge our customers twice, and we also won't forget the delivery to deliver. Because otherwise, I'm pretty sure that the customer will quickly go to another food delivery service. So ideally, what we would like to have is workflow-like semantics for our code without really using a workflow manager, because we want to write code after all, right? So workflows as code. The first thing we need to be aware of is that our process that runs our function can fail at any point in time, right? So someone might trip over the power cord of the server, or might accidentally delete the deployment, or there are a plethora of other reasons why a process can stop. So first of all, we need a system that keeps track of it and retries in case that this happens. We could use, for example, something like Kubernetes and deploy it as a Kubernetes job to make sure that this gets eventually executed. If we have set this up, then we need to be aware that previous attempts might have completed already some of the steps, and this can be a problem, because we don't want to charge our customer twice, right? In some cases where you can put all the steps that your function is supposed to do within a single transaction, then we can rely on the ACID properties, which guarantee that everything, either all or nothing has happened. So retrying is quite simple. In this case here, we're interacting with an external payment provider like Stripe, where this is not so easily possible. So the next best thing you can do is actually to make all your calls idempotent, so that rerunning them wouldn't have an additional side effect. That works in many cases. However, there are some cases where this also is not really applicable. Think, for example, that you're doing a very expensive computational step, which you don't want to redo because it's just too expensive. Or think that you have a sleep, and if you redo the sleep, you will sleep twice the duration, and then it will definitely result in a hungry customer because the food will not arrive on time. So a naive approach to solve this problem is to try to track the progress of your service. We could, for example, use an external database to which we write whenever we have successfully completed one of our steps. This could then, if we do this, then we would also add a check around every step, whether we have done this step or not, and thereby we wouldn't redo steps we have already completed, right? The code, while not very beautiful, could look like this. The problem, however, is that this wouldn't work, at least not in all cases, because now we're interacting with an external service, like our payment provider, and we're trying to write to a database. And ideally, this should happen atomically within one transaction. But this would require like a distributed transaction, which not many systems support. So we can still fail after we've just completed the payment, but before writing the update to your database. And if we would retry again, in that case, we would redo the payment, right? Because it's not persisted in our database. So that's kind of a bummer. So this is not the right solution. Another problem we will face with our service is that we are interacting with external services over the network. And as we know, network communication is unreliable and messages can get lost, right? So we need to add, for all external calls, a retry mechanism. And also probably we want to add some kind of timeout, because if the external service is permanently down, we want eventually to give our client that called the service a response. Retrying invocations, however, poses also another requirement for the called service, which needs to handle duplicate messages, because we cannot distinguish between a lost message and just a service that is slow at processing them, right? So yeah, we might just have sent multiple requests to process the payment to Stripe. And actually, the same requirement also applies to our food ordering process, because someone needs to invoke it, right? And this someone might also retry. And if we didn't respond fast enough, we might get the request twice. The way to how one could add like a retry mechanism with timeouts and their handling could look like this, which is definitely also not super beautiful, and it adds quite a bit of extra code for these non-functional requirements. As our external services that we are calling can be down, so can we be unavailable. So for example, after we have not told the restaurant to prepare the food, the restaurant will signal us via a webhook that the food is ready, right? What if we are down when this signal comes? The restaurant might retry a couple of times, but if we didn't restart our process in time, the signal might be lost, and we will be forever stuck at the step where we are waiting the signal from the restaurant. So what people usually do is they add an additional system to the mix, which gives them persistence and high availability. Something like a message queue like Kafka, which records the external signal, and which can then be read by our service to go to the deliver step. Here, the code actually looks almost the same. However, we added a new system that someone needs to deploy and manage to the mix, and which increased the overall complexity of the application we are building. So also not the perfect solution. Assuming that we have implemented all these things correctly and solved some other problems I haven't managed, we actually now deploying our service to production and are monitoring it to see what it's doing. And there we actually realize, when profiling it, that we spend a lot of time actually doing nothing, waiting for other services to get back to us with a response, waiting that the sleep completes, and so on. And during all that time, we're actually occupying resources that could be used for something else. And if you, for example, deploy on some serverless function platform, then you would actually also be charged for the wait time. So wouldn't it be great if you would only be charged for the time you used the CPU? That is actually not so easy to solve, and therefore let's table this point for a few slides before we get back to it. So what I wanted to demonstrate in these few slides is that building reliable services is hard. The problem is services or applications can always crash, and all the state that is not persistent, intermediate state that is not persistent, will be lost. So what people usually do to mitigate this problem is adding retries and adding additional systems to make the communication reliable, the compute, and the state durable. So for example, using message queues for recording the webhooks that we might have missed, a database for storing the state of the service and its progress, or using a workflow orchestrator to ensure that the service really completes, or for timers using something like a cron job for running the delayed operations. And all of this is a lot of work on non-functional requirements. So time you spend not implementing the core business logic that your company probably pays you doing. So wouldn't it be great if there were a system that can take care of many of these concerns and lets you focus again on the core business value? And you might have guessed it, that's where Restate comes into play. A system which has the goal to make the development of reliable, consistent, and scalable applications simpler again. And the way it does this is by providing distributed, durable versions of your everyday building blocks. So with durable execution, your function services can now handle retries, recovery, and idempotency very easily. With durable promises and RPCs, your communication between services, processes, and across time becomes fault tolerant. And Reset also offers an abstraction called virtual objects, which allows you to assign or to store state with a service instance, so to make it stateful, which is a lot more, allows you to express many more programs. And on top of it, it gives you an easy to reason about a concurrency model. So with these building blocks, how would the implementation of the food order workflow look like with Restate? Here on this slide, by the way, I know the code might be a bit small, so if you can't read it properly, there are plenty of free seats up in the front. I will show a bit more code later, so it might be worth the relocation. Okay, here I've implemented the food order processing workflow using Restate's TypeScript SDK. What we see is, first of all, without looking at the details here, that we sprinkled a few Restate context calls in there. I will explain in a second what this is for. But what we also see is that this code doesn't contain any retries. It doesn't contain any additional logic for partial recoveries or for making calls, for deduplicating calls. It's, I would say, almost looks as the pseudocode on one of the first slides. It's quite pure. So let's zoom in a bit on what is happening here. Okay, that is, okay, now it shows it correctly. The first thing we notice is that we have an asynchronous function, and it's not a normal function anymore, it's a durable function. And this is indicated by the first argument, which is the restate context that we pass in. This restate context allows this function to interact with restate, its underlying durability layer. Then the second argument is like the normal parameter, which is the containing the order ID or information about the order that the user has placed. The first thing we need to do in our order workflow, food order workflow, is processing the payment. Since we are interacting with an external system and the call to the external system can fail and we need to retry, we need to make it idempotent. And for that, Restate allows you to simply generate an idempotency token, which is the first line you see, via context.rent.uuid v4, which generates an idempotency token, which is also memorized. So that means that in case of a recovery and a retry, the very same value for this token will be returned. So it's a stable value that we can use in subsequent calls, like the call to the payment client. So it will always see the same idempotency token on retries, making this call effectively idempotent. What we see in the second line is that we wrap the payment client.charge into a context.run. That's the way you tell Restate that this operation should also be memorized and made replayable. So that in case of recovery, if you have done this step successfully before, you wouldn't redo it. And by the way, more or less all Restate context calls are being memorized and replayable. The next step would be waiting for the delivery delay. And here we use the context.sleep to register with the Restate runtime when to wake up. And by doing that, we actually we can tolerate failures of the process, because now the runtime knows when this process wants to resume and can in case of a failure do that. The next step would be calling the restaurant to signal the preparation of the food, and await for a signal back from the restaurant. The way it would be implemented with Restate is to first register a durable promise by calling context.awakeable, and then sending the ID of this promise to the restaurant client, so that the restaurant client later can issue a webhook to the Restate runtime, which will complete this promise, which we are awaiting in the third line here. So once the webhook has arrived at the runtime, the runtime will tell the service, look, this promise is now completed, you can now continue with your work. Again, we are wrapping the restaurant client.prepare call in a context.run to memorize this the side effect. And okay, this doesn't. All right. And last but not least, we kick off the delivery of the food order by calling another Restate service. And here we call it a bit differently because it's another Restate service. We would call context.serviceClient and provide the service specification in the form of the delivery service. This returns us a fully typed client on which we then call the deliver call. Here, noteworthy is that we didn't have to add any idempotency token or so, because it's an internal Restate, like Restate to Restate service call. The runtime will automatically make sure that the call is idempotent. And we are waiting here the result of the call. So once the delivery has been done, the food order workflow would also complete. All right, so I hope this makes it a bit clearer for why we sprinkled the Restate context calls into the code. Still, I think the code almost reads as if it were the pseudocode. Not a lot of non-functional requirements related code here. So to sum things up, what have we implemented in this small example? So we implemented a fully durable executed service handler without having to implement the manual retry logic or the partial progress recovery. We used a durable timer to register when to wake up, but we didn't have to deploy like a workflow orchestrator or use some cron jobs for doing that. We are awaiting callbacks without having to deploy and operate an additional system like a message queue. And we also have seen how to interact with other Restate services without having to implement retries, timers, or deduplication. And the important bit here on the slide, which I would like to highlight, is not the things we implemented, but the things we didn't have to implement for a function that is fully resilient against many infrastructure faults. As I've mentioned before, Restate also supports stateful services, which are called virtual objects in Restate. We would have probably called them durable objects if this term wouldn't have been trademarked by Cloudflare. But yeah, so it became virtual object. And virtual object is identified by a key. And every virtual object instance is the owner of a set of key value pairs, which is kept highly consistent and exposed as a key value store abstraction to the user. Additionally, for virtual objects, Restate provides a specific concurrency model, which says that invocations for a virtual object instance are serialized. So this means that at any point in time, there can be at most one handler active for a given virtual object instance. And what this gives you is that you don't need to add additional guards when accessing state. So Restate makes sure that there is no race condition and there is effectively no concurrency for a given virtual object instance, which makes it really simple to use. So the way you would use a virtual object is what you see at the bottom of the slide. You register a virtual object by the restate.object call, you give it a name, and then you define your handler. And this handler reads the scene state from the key value store and increments its value and returns the previous value. That's it. So I hope by now you have seen that writing restate applications is very familiar to what you have probably done before. You simply write function and services. You don't have to think in workflows or activities or other concepts. The code you've written, the services, you can deploy as any other services you deploy. You deploy them on Kubernetes, Fargate, on Lambda, you name it. There's no special requirements for workers or runtimes. It's just what you're used to use. And what I will show you in the demo later is that Restate, the server itself, comes in a very compact form factor, which is a single self-contained binary, which is really easy to deploy and operate. So you can think of it a bit like the Redis or the Red Panda of workflow engines if you used any of these two systems before. For those that don't want to deploy Restate yourself, this month we will also release a serverless cloud service, which you can use. So you've already seen that you can use Restate for building workflows as code. But you can also use it for running asynchronous tasks by using Restate's durable timers. You can use the state abstraction to build persistent state machines, or use durable promises to connect to external systems through Restate. Or, if you like, you can also go full in on Restate and build your whole application on it and reap the benefits of not having to build idempotency in your or deduplication in your services, because the Restate internal service invocations, as I've said, will be automatically deduplicated. Or what you can also do is you can hook up Restate with Kafka and build an event-driven application with the benefit of being able to express the logic at the simplicity of synchronous code. So now you might ask, how is all this working? The way it works is that Restate, or the runtime of Restate, sits between your clients and the services. And it turns them and acts as kind of an event broker or reverse proxy, and turns your services that can be deployed on any kind of infrastructure into durable handlers, workflows, or stateful objects. If we zoom in a bit more, we see, well, as I've said, okay, this is not loading. Okay, that's correct. As I said, Restate sits between your request events and your services, and keeps track of the three dimensions of them, of the communication, the execution, and state. And every time something happens, like your service calls another service or makes progress in its execution or updates its state, and this will result in an event that gets appended to Restate's internal log. So everything goes into a single log. That's important here. And that way we can persist the progress and also keep things consistent. So if a new request arrives, the first thing that would happen is it would get appended to the log, so that in case something crashes, also the Restate runtime, it can be restarted and recovered from durable storage. Next, the request would be sent to the service endpoint that you have registered. Additionally, the request might be enriched with some extra information like state of the service or the progress a previous invocation of the service has made. Then, as your service code makes progress, calls some Restate context calls, it generates progress that is being streamed back to the runtime, where it gets appended to the log again, and thereby made durable and replayable. And this continues until your service finishes and generates a response, which will also be committed to the Restate log and then sent back to the client that did the initial invocation. All right. Now let us take a look at how Restate implements durable execution. There are different ways to do it. One way could be taking a memory snapshot of your process, but Restate decided to implement the journaling approach. So when Restate starts a new invocation, what it will also do, it will create an invocation journal. And as your service goes through or makes progress through its code, it will generate more journal entries that get appended to this invocation journal. This happens whenever you do like a Restate context call. So here in our example, we have successfully completed the process payment step and the sleep, and it got appended to our journal here. If now a crash happens, Restate would notice that and would re-invoke the service again with the persisted journal. And then the SDK, based on the journal it has, can basically know which of the steps of your function has been already been completed or not. For those that are already completed, it will simply return the result from the journal to the caller. And this basically prevents the re-execution of the actual step. And by basically doing this from the beginning of your code, you can basically reconstruct the state which you had when the crash occurred, and then continue from there. All right, another really cool feature based on durable execution is that Restate supports suspending invocations on awaits. So with durable executions, we are able to resume a service invocation wherever it left off. Right? Now, what Restate can also do, it can suspend an invocation by forcing a graceful failure, if you wish, by throwing like an artificial exception in your user code, which makes the invocation terminate. And then it can resume it at a later point in time. This can be, you might ask, why is this useful for? Or what is this useful for? This can be useful for cases where the runtime knows that your service is sleeping for a long time, for example. Or if, like an invocation, has called another service and the response just takes some time to get sent back. If that happens, the runtime can decide, look, you're waiting me too much, I will suspend you. But I will promise you that I will re-invoke you once I have more events, information, which make me think that you can make progress with your invocation. And this allows to free resources that could be used for something else. And this is particularly interesting for serverless functions, like if you deploy on Lambda, for example. Because on Lambda, you don't want to wait, right? This is known an anti-pattern. But with Restate, you only active for the time where you need the CPU. And so you can, with Restate, you can build and deploy Lambda functions that call each other and await their results. Which this is known as an anti-pattern, but since Restate will suspend you, you don't. This is now possible with Lambda deployed functions, which is really cool, I believe. And then I've mentioned that Restate makes sure that for Restate internal calls that they get deduplicated so that they become effectively idempotent. This also works end-to-end. And the way it works is that a client making a call against Restate will attach an idempotency key as an HTTP2 header, which will allow Restate to correlate requests with each other. So if like a reach-write request comes in, and Restate sees that it has already seen a request with this idempotency key, it can either latch this request onto an ongoing invocation and return the result once this completes, or if the invocation has already completed, simply returns the result to the caller, which is a very powerful feature, I believe. All right, so much for the theory. Let's now take a look at a concrete bit more concrete example with Restate and how it looks like with the workflow implemented and running. So The demo scenario is the basically I've implemented the order workflow on Restate, so the same workflow we talked about on the first a few slides. For a bit of eye candy, okay, 1 second. Sometimes it doesn't load the. Okay, now it's loaded. For a bit of eye candy, we actually created a small web UI that generates the HTTP request that goes to Restate and then kicks off the order workflow. The order workflow would do then the payment processing and notifying our restaurant. And additionally, call then another Restate service, the delivery service, to handle the delivery. To visualize the progress of our workflow, we have added an order status service that is being updated by the order workflow and the delivery service with the status of the order and the ETA of the delivery. All right. Now let us take a look at the code. I hope it is big enough so that everyone sees it at the back. Wait, is it not big enough?
Maybe a
bit more. Okay, then we have really little space on the screen, but let's see. Okay, so here this is the definition of, or starts the definition of the order workflow. Since our orders are keyed and we want to leverage Restate's concurrency model, we implemented this service as a virtual object. So that's why we use restate.object. We give it a name. And then we define our only handler, which is the create handler. And the create handler gets the restate context passed in and the order parameter. The first thing that is slightly different to what I've shown you before is that we create an additional client to update the order status workflow, order status service. So basically reflecting the state where we are. Since this service keeps state, this is also implemented as a virtual object. So that's why we create an object send client where we specify its signature and provide the key of this virtual object. Next, we do update the status to create it and then do the payment processing. Here, that is exactly the same that I've shown you before on the slide. We generate first the idempotency token and then wrap the call to the external service into our context.one. Here, small addition, in case the payment couldn't be processed, we would reject the food order. Then we update our status to scheduled and sleep for the delivery delay, and then notify the restaurant that it should prepare our food. And we get the signal back from the restaurant by letting it complete this durable promise that we have created here and are awaiting in this line. And last but not least, we call our delivery service, there we call the deliver handler, and await its completion. And once this is done, we set our status to delivered, and that's it. All right, so much for the workflow itself. Let's quickly take a look at how we would expose this service as an endpoint. The way you do it is basically by creating an endpoint, then binding the different services you want to expose, and then tell that you want to start it as an HTTP server, which by default listens on port 9080. All right, that's all. Now, let us see how it looks in action. So I've already started the Dockerized web UI and the delivery service. Now let us start the runtime. So we do this, can do this. Wait, actually, let me. And that would be the command. I've given a config file, and it would start our server like that. If we scroll up a bit, we do see the nice Restate logo as ASCII art. We do see that we have started the Restate server, and then it will tell us that it has started a few services. The ones that are most interesting for us now is the admin service, which we will use to register the service, and then the ingress service where we send our requests to. The next thing we do is we start our workflow. Our workflow service. Now we see we have started this endpoint listening on port 9080. So to connect now the service to Restate, we need to register it. And here you can use our CLI, and you want to register a deployment which runs on localhost. Localhost. I set 9080. All right. So let's see what happens. Okay, let me make this a bit larger. So what happens when you tell Restate that there is a service deployment running at this address, the runtime will send a discovery request to it. And the SDK will respond with the discovery response, which contains all the services that this endpoint is running. And concretely, that would be our order workflow, which is of type virtual object and exposes the create handler, and our order status service, the service that keeps track of where we are. And here we have a couple, like three handlers that are used to update the status. All right. That's all to hook up the runtime with your service. Now let us place an order. So let's say we are really hungry and we actually order a pizza and a sushi box. But we will only be hungry in 15 seconds, so let's add a small delay. And then, yeah, we like bytes and bytes, so let's order it. So this should, let me actually check, that should actually do something, but apparently, oh, okay, I've forgotten something, which is pressing yes here. So it's not registered yet. So the runtime actually didn't know about the service yet, so it rejected it. Let's actually redo it. Now we do the same thing, check it out, and that should kick things off. And as you see, it first goes into the created state, then the scheduled state, then we wait for 15 seconds to run the preparing step, which then is meaning the restaurant is now preparing our food, which is hard-coded to take 5 seconds, and then the delivery person takes over and goes to the restaurant to pick it up, and then brings it to our customer, which takes in this world like 20 seconds. Then we will see the workflow has completed and is delivered. Nice. Okay, what we actually see here in our Dockerized restaurant service, that we have like that our restaurant processed our order, the other 721, and we also see in our logs here, which is showing I hope you can read it, which showing the steps of the order workflow. First of all, see that we have run the payment step and then have gone through the individual steps of the workflow. Now, what happens if something crashes? Like if we crash in between of our order workflow. To simulate that, I have this fail function, which effectively simply just throws a exception. And since this is actually a non-transient exception, we will never make progress because we will always fail at this point, right? So let's see how this looks like with in our app. So I order again a pizza. This time delivery should be right now, and now we place it. So what we see, first of all, here is that we are kind of stuck in the preparing state. I mean, let's wait maybe a bit more than 5 seconds because that's the time that the restaurant needs to prepare. But I guess, yeah, that's longer than 5 seconds. So apparently we don't make any progress. So we are stuck. If we now look at, let's see here, look at our log output of the service endpoint that runs the workflow, we do see, okay, that is really not formatted well, but we do see that actually our function completed with an error, and it actually also printed like the error message that I've added here. And what we also see is that this apparently seems to be retried. The reason is that Restate has realized, okay, now this invocation has failed, I need to retry it. It doesn't know that this error is non-transient, so that it can't make any progress. But what this basically allows you to do is actually debug this problem and fix it. So how can you do this? Or how would you do this with Restate? So you can, if your workflow is stuck for any reason, the first thing you can do is you can ask for stuck invocations, and you can use again the Restate CLI, and you can first of all list the ongoing invocations. And what we see here is that we actually have like an order workflow create invocation running, and it is being retried. So it seems to be failing, and we see that actually, yeah, we are failing for something went wrong reason. So okay, that is our first indicator to further dig into it. Let's look a bit more closer at this concrete invocation. You can do this by calling invocation get and providing the invocation ID. And then you get a few more details about the invocation. The interesting part here is actually looking at the invocation journal. And here we actually see where exactly we are failing. So we do see that we updated our status service. We did we ran the side effect of the payment processing. Then again, we updated our status service. We completed our sleep. Then we registered an durable promise, ran the side effect of the restaurant, and the send. And then the next step, we are failing. So based on this journal, you could already reason where the error might be. But to be sure, let's actually, because we are still running it locally, right, and from our IDE, let's step through it and see what we see. So let us set a breakpoint here. And this should be triggered because Restate is constantly retrying. And now we can step through the code and further debug what is happening. And all the steps where we call a Restate API, which has completed, we will not rerun. We will read the result from the invocation journal and return that. So the token that we have created, you can see it here, is exactly the same as we have been using for any of the previous retries. So as we go through here, we do see everything works fine until, yeah, okay, we apparently have introduced like an exception. So let's actually get rid of it and see what is happening. All right, 1 second. I need to make this a bit smaller. So we see here, so in the Web UI, we still see we don't do any progress because I first need to save this so that it gets transpiled, and then I need to remove the breakpoint and resume the invocation. So now we have removed the failure or fixed our code, and our workflow makes progress again. and completes, hopefully in, okay, apparently 20 seconds. And I hope you believe me that we will reach the delivered state now. And this makes, or what this should demonstrate is that the development flow of implementing like a restate service can happen completely locally, and you can attach your IDEs and use the tools you're used to use. Now let's assume because we have tested it locally and everything works, we want to deploy it. We want to deploy it on our production environment, which is Lambda. So what you need to do for this to happen is we need to change our endpoint from an HTTP endpoint to exporting it as a Lambda handler. So again, we register, like we create an endpoint, bind our services to it, and then create a Lambda handler. That's all we need to do. Then the next thing is we would need to deploy to Lambda. I've already done this to save us some time. And then we need to register this Lambda service with Restate. And the way we do it is first we retrieve the Amazon resource name. That's what we need. And then we register this service. Restate, deployment register. Oh, sorry. Register. All right. So now what happens is that we are talking now to our Lambda deployed service. We register it. Good. And now let us run the example again. And now what we are seeing is basically the same. The workflow is running, but now if we look at the where the deployment, like where the function is running, we see it runs now on our Lambda, no longer locally. And you didn't have to change any line of code, or I mean, you have to change one line of code to move it from a local development to Lambda. And the reason why this is possible also, because remember we have a service calling another service and awaiting its response. This is easily possible to deploy this on Lambda because we don't wait there. We suspend invocation, so we don't pay for the wait time there. So you can, which was before an anti-pattern, you can now do and move easily from one deployment to another deployment. All right. Now let us go back to the last two slides. Then I'm done. So where is Restate today? Restate is under development for like 1.5 years. And actually, the initial designs and ideas date back a bit, have been developed a lot earlier, to be honest. The Restate has been open sourced in December 2023. And currently, Restate supports the TypeScript, Java, and Kotlin as SDKs. We will soon add more. This is a bit demand-driven, to be honest. But Restate itself is language agnostic and can be made work with any type of tech stack you want to use. First, users are putting their applications into production, and we are rapidly incorporating any feedback we gather from our users. In the next month, what you can look forward to is that actually this month we want to release an early access to a serverless managed Restate platform, and we also want to add a new, a more expressive workflow API that makes implementing workflows even nicer. And we are currently fully focused on implementing the distributed aspect of the distributed runtime of Restate, which will give you high availability and also scale out behavior. So in case you have very large workloads, it should also be possible for Restate to handle them. And with that, let me wrap up my presentation. So I hope what you've seen today is that you can build resilient, consistent, scalable applications with Restate. It is as simple as implementing function and services, just code. You don't need to learn a new DSL or deploy queues or workflow managers. It's very simple. You can deploy your services on your existing infra, may it be a FAS, Kubernetes, servers, containers, can be on-prem or in the cloud. And Restate comes as a single binary with all batteries included for easy operations. And with that, thanks a lot for your time. I hope you have enjoyed the talk. If you want to stay up to date, follow us on Twitter or LinkedIn, or give us a star on GitHub if you like what we're doing. But most importantly, if you want to try it out, please give it a spin and let us know what you think. Like, your feedback is the most valuable source of how to make Restate better. And actually, if you want to do this and have a chance to win some prizes, tomorrow there's a hackathon where you can build a Restate application. It's happening here and free to participate. Yeah, thanks a lot. By the way, if there are any questions, we might be a bit short on time, but we can also take them offline, or we have a booth where we can talk about them.
I have a question.
Yeah.
I saw that you in the code you have assumptions that reside a context, right? This context allows you to manage some state inside your function. But my question is, for example, you can say you can.
There's a new item of swag that just arrived, not sure the new item of swag, the Perfect Systems Technical Journal. So feel free to pick one up and read it with us. We're swag guide.
I was wondering that you can use your context to request, to make an HTTP request to maybe place the order or whatever, right?
Yes.
My question is, this function that you are calling from the context, with the context, this function inside also have a context or not?
No. Let me actually go back to the snippet of code. 1 second. You're probably talking about
Payment client charge, for example.
the payment client charge. Yeah. So what you do in the context.run, this method takes a closure. I think I